Connect. So my name is Oleksii Vasylenko. I am a graphics engineer in Samsung Electronics. Before starting, I guess you maybe wonder how can be Samsung related to game development at all. So let me introduce our Galaxy Game Dev program. Since November 2015, engineers from Korea, UK, US, and Ukraine are supporting game studios all over the world to optimize their game titles for mobile. And as you may know, the common goal of optimization, especially for mobile, for like AAA or AA game titles, is always like finding some trade-off between quality and performance. So it's like tug-of-war battle between them. Better frame rate means lower resolution and less graphic effects, and better quality means lower FPS and less battery life, and so on. So does it mean we cannot achieve some really cool high-level graphics with pretty good and stable frame rate like this? This is our protostar demo. We shown it on MWC in 2016, and it was really cool. So, and actually that means we can do that. But how exactly can we chase both quality and performance? How can we extend the rope in this tug-of-war competition? Every year we have much more powerful CPUs and GPUs on our mobile devices. We extend battery life, we solve a lot of issues like thermal throttling and so on. But all that is just like hardware side optimizations, hardware side improvements. If we're talking about software side, we have just like few OpenGLES extensions that can be helpful only some specific cases, in some specific situations. But we believe, finally, we have some general solution for that, and it is Vulkan. So with Vulkan you can get better quality with even better performance. But what is it, Vulkan? So first thing you should know about it, it's not one of another followers of OpenGL. It starts from absolutely first principles. It has clean modern architecture. It's ultra lightweight. CPU overhead is greatly reduced in Vulkan. And it's multi-thread, multi-core friendly. It cross-platform, and there is no driver magic anymore, like in OpenGL case. So everything should be controlled explicitly by developer. And actually, Samsung is one of the Vulkan pioneers. So even before Vulkan was released to public, we made a lot of concept demos to show Vulkan benefits and to understand how to use it in a proper way. So as you can see, even at that time we get much higher FPS in Vulkan case with even lower CPU usage. After that, on MWC, as I mentioned before, we shown our protostar demo, and we presented first mobile ever with Vulkan support. It was Galaxy S7, and the next logical step was to go on with real games, real game cases. And at that time we realized that it's not so easy actually to get benefits if we are talking about real games, because the engine architecture was not quite good for Vulkan. But even at that time, for example, in Vainglory case, we got consistent 60 FPS even in thermal throttling situations. And for another game, Hit, we add more post-processing stuff with same frame rate compared to OpenGL. Since that time till now, we have more and more work to do. Now we are working with more than 30 game companies to optimize their games. Here you can see just a few of them. And so, as I told before, there is no driver magic anymore, so you should control all stuff explicitly, and that means it's really important to use Vulkan in proper way. So let's talk about some best practices. I want to start from command buffers. What is it? So it's an object used to record some commands which can be subsequently submitted to a device queue for execution. There are different kinds of commands like drawing commands, uploading commands, updating states commands, and so on. And as you may know, on Android, we usually use triple buffering. So the regular logic may be like for each back buffer, we will use its own command buffer, and just when we will go back to the same frame buffer, we will just reuse that command buffer, so as you can see here. But in that case, sometimes you can have like a performance gap because you need to wait for command buffer submission completion. So you need to wait for rendering execution. It's not good. Much better logic better solution will be like this. So we will just check if all command buffers are not ready for now. We will just create new one, and we will go with it. As practices show, usually 6 or 7 command buffers is enough for game, so it's not too much. Another important thing regarding command buffers, you should minimize command buffers count per frame. But that doesn't mean you should use only one. Always, because in some heavy cases, if you will use just one command buffer, you can get some texture corruption like here. So we recommend to split command buffers, one for recording drawing commands, and second one for recording uploading commands, transfer commands. The other important thing is pipeline management in Vulkan. As you may know, pipeline is an abstract scheme of how unit of work is proceed, and it consists of few logical stages. You can see them from top to the bottom. And pipeline barrier is like memory dependency between some stages. Here is pipeline barrier API, and we're using source stage mask to describe which commands must be finished before this barrier, before passing this barrier, and destination stage mask shows for which commands for which operations execution haven't been started yet. So, for example, if we will render something to our texture and we want to use it for post-processing, so we will use it in next fragment shader. If we will set our barrier like this, that means we will set it pretty early. We will have a so-called pipeline bubble. So you can see here some gap. Because actually we can just execute our vertex jobs subsequently because they not depend one of each other. But if we will set our mask like this, we can execute next vertex job just right after fragment job completion. So that is, in this case, you will get performance even worse than in OpenGL. Correct way is like this. So we will just wait for writing exactly to our texture, and then we will use it in our fragment shader. And so here you can find just performance difference just because of that. So here we have 34 FPS and here 39, so 5 FPS difference, which is pretty much. But on the other hand, if you will set up your barrier very late, that means you can get some flickering, some artifacts, because some memory will be just garbage and you will use it in your shader. That's also bad, so you should manage all this stuff efficiently. Render passes. Render pass in Vulkan represents a collection of attachments, subpasses, and dependencies between subpasses. And also it describes how that attachments can be used. Begin and render pass are really performance cost operations, so you should manage them properly. That means you should avoid some useless resolving render targets. You should reduce your render passes count. You don't need to use. It's really bad to have some empty render passes, which are just pretty useless, but it will cost you some performance. Another important thing is you should recognize where functions should be called, inside or outside render pass. For example, if we are talking about clear attachment call, if you will call it outside render pass, you may have such artifacts, such black squares. Memory management is also very important if we are talking about Vulkan. There are different memory types in Vulkan. So in OpenGL, we have just like map and unmapped memory stuff. Here, if our memory is like host visible, it will also perform same calls. So we also can use map and map memory, and we will get actual pointer for our memory. But there is another type. It's called device local. This memory don't provide you any access to actual pointers, so you should use internal Vulkan API to copy something inside it. But according to spec, it is the most efficient memory type in Vulkan. That's actually for PC case. So on mostly mobile devices, there is just unified memory. So if you will use device local memory like for PC, you will do some extra copying, which is CPU cost for mobile. So it's better to avoid them, especially if we're talking about dynamic objects. So I will explain it more precisely. If we want to fill the data on device memory, we need to first create on Vulkan some so-called staging buffer which have actual pointer access, copy our memory there, and then use internal CMD copy buffer, and after that our memory will just fill. So we will have one more extra copying. For static objects, we will do it just once and it will be fine. But if we're talking about dynamic objects, we need to do that frame by frame, and it will be performance cost, especially for mobile. Here are some just as a general recommendation. So I want to draw your attention to some exactly key points, like almost all objects in Vulkan are reusable, so you should cache everything as much as you can. Especially it's related to pipelines, because creation of pipeline is a really expensive operation. And another thing is, before even starting doing something, you should consider your device limits, because every GPU has its own limits, and sometimes you may have some issues because of that, which will be hard to verify later. So please be careful with this. Another good thing in Vulkan, I can even say great thing, is validation layers. You don't need to call it like GL get error everywhere in OpenGL. So in OpenGL, we just use it like after every actual call. In Vulkan, it's enough just to enable them on initial time and implement simple callback. And after that, the driver will gather all necessary information for you. And in case of OpenGL, we have just like error code, and that's all. In case of Vulkan, we have much deep information. It will be really helpful to fix your bugs, your issues. Yeah, you may think that Vulkan is pretty complicated API, but the good thing is some game engines already support it. In collaboration with Unreal Engine, we provided support for Vulkan. Also, we worked with Unity to optimize the game engine for mobile. And if you will do everything, if you will follow all the specs, you can achieve some great results. This is a Lineage 2 Revolution game. On the left side, you can see OpenGLES performance. On the right, Vulkan. You can see that it's pretty better, maybe 10 or 15 FPS better. So it's really cool. And wrap up. We believe that Vulkan helps you to create high-fidelity games on mobile. API is pretty complicated, but the most popular engine already supports it, like Unity and Unreal Engine. So actually, all is set up for creating high-quality games, and let's move it to the next level together. Thank you. If you have any questions, please feel free to ask.
I want to ask about Unity. So, does it work with any Unity version, or it's only for 2017?
Actually, I guess support start from 5.6.1, so it was pretty early. Actually, these days we release the first Vulkan-based Unity game on Korean market, so it's supported for a long time before.
Okay, thank you.
Awesome. Well, thank you so much.
Yeah, thank you, guys.